Carbonyl compounds. Bonding structure of carbonyl compounds. The carbon is sp2 hybridized and 3 sigma bonds are planar in structure. The unhybridized 2p orbital of carbon at 90 degree, it overlaps with 2p orbital of oxygen atom to form a pi bond. See the structure. Carbon and oxygen are present in the planar. Unhybridized p orbitals are perpendicular to the plane. The unhybridized p orbital overlap to formation of pi bond. As oxygen is more electronegative than carbon, therefore the carbonyl bond is a polar bond. Carbonyl compound structure. The bond is polar bond due to different electronegativity. Differences between aldehyde and ketone. At least one hydrogen atom attached to the carbonyl group called as aldehydes. For example, formaldehyde, acetaldehyde. Two carbon atoms attached to the carbonyl group such as ketone. For example, acetone and butanone. Formation of aldehyde. In general, alcohols are oxidized into carbonyl compounds. Primary alcohol oxidized into aldehyde, secondary alcohol oxidized into ketone. Some cases, primary alcohol oxidized by strong oxidizing agent, it oxidized into aldehyde and further oxidized into carboxylic acid. For example, potassium permanganate is a powerful oxidizing agent. It oxidized into alcohol and ketones. Corresponding carboxylic acid in alkali medium. Other oxidizing agents, manganese dioxide, Jones reagent. Jones reagent means dichromate dissolved in the sulfuric acid, pyridinium chlorochromate, pyridinium dichromate, and periodic acid. These reagents are mild oxidizing agent. It oxidized only for alcohol to aldehyde, not for acid. Oxidation. It provides a way of differentiating between aldehyde and ketones. It mild oxidizing agents are best. Aldehydes are easier to oxidize. Powerful oxidizing agent oxidize ketone to mixture of carboxylic acid. Already I said you, the powerful oxidizing agents such as potassium permanganate oxidized into aldehyde as well as carboxylic acid. Carbonyl compounds reduction. Functional groups containing multiple bonds can be reduced. Carbon-carbon double bond is reduced to carbon-carbon single bond. Carbonyl bond is reduced to alcohol. Nitrile bond reduced to amine. The source of hydrogen donor. Hydrogen free radical, hydrogen molecule, hydrogen electrophile such as protium ion, hydride as a nucleophile. The reactions of hydrogenation, the hydrogen reduces carbon-carbon double bond as well as carbonyl bonds. For example, acrolein have carbon-carbon double bond as well as carbonyl group. The acrolein treated with metal hydride, it reduced into alcohol as well as alkane group. Explanation. Carbonyl bond is polar bond, so is attacked by the nucleophile hydride ion. Carbon-carbon double bond is non-polar, is not attacked by nucleophile hydride ion. Carbonyl compounds nucleophilic addition reaction. A nucleophilic addition reaction occurs with both aldehydes and ketones. It involves addition to carbonyl double bond. Unlike alkenes, they are attacked by nucleophiles. Nucleophilic attack is at positive carbon center due to different electronegativity of atom. Already we have seen the previous slides. Oxygen is more electronegative than carbon. Therefore, electron clouds are moved towards the oxygen. The carbonyl carbon create the positive center. Alkenes are non-polar and attacked by electrophiles undergoing electrophilic addition reaction. Reduction with hydrogen. Reagent hydrogen. Catalysis nickel or platinum. Reaction type hydrogenation reaction. Products alcohols. Aldehydes are reduced into primary alcohol. Ketones are reduced into secondary alcohol. See the equation. Acetaldehyde reduced at the hydrogen atmosphere, presence of nickel or platinum as a catalyst. It produces a primary alcohol such as ethanol. Nucleophilic addition reaction. The reagent is a hydrogen cyanide. See the equation. Acetaldehyde treated with cyanohydrin to produce a cyanohydrin molecule. Notes: hydrogen cyanide is a weak acid and has difficulty dissociating into ions. Hydrogen cyanide ionized into H plus and Cn minus. Cn minus means cyanide ion. The reaction is catalyzed by alkali, which helps to produce a more number of nucleophile. See the mechanism. Step 1. The cyanide ion acts as nucleophile and attack the singly positive carbon and one of the carbonyl bonds breaker. A pair of electron goes to oxygen. See the mechanism. Acetaldehyde present in the plane of the position. The cyanide ion attack of the carbonyl carbon. At the same time, the electron pair transfer to the oxygen. And the electron pair transfer to the alkoxide ion accept the hydrogen to formation of cyanohydrin as a product. The stereochemistry of the cyanohydrin product. Acetaldehyde present in the planar structure. The cyanide attack above the position and below the carbon to formation of optical isomeric product. This product is the enantiomeric product. Carbonyl compounds. Reduction with the sodium borohydride. The sodium borohydride is a hydrate donor. These hydrates are act as a nucleophile. In general, aldehyde and ketones are reduced into alcohol. Primary alcohol reduced into